On pages 9 and 10 of our Unit 3 notes, we are graphing compound inequalities. The first type of compound inequality that we are graphing is the AND compound inequality. This is the simplified version of an AND compound inequality. This statement says x is greater than 1. X is greater than 1 is equivalent to 1 is less than x, and x is less than or equal to 4. We are never going to write our final answer for a compound inequality with the word AND. We will always rewrite it with the variable in the middle stating this greater than statement, x is greater than 1, followed by the less than statement, x is less than or equal to 4. When we are graphing this compound inequality, we are looking for the overlapping region of the two simple inequalities, the values that are both greater than 1 as well as less than or equal to 4. So x is greater than 1. Open dot at 1 does not include the value 1, as well as all values to the right of that open circle, so any number greater than 1. X is less than or equal to 4 can include the number 4, as well as any value x less than 4. So x is greater than 1 goes infinitely to the right, x is less than or equal to 4 goes infinitely to the left. My graph of x is greater than 1 and less than or equal to 4 is just the overlapping region. The overlapping region is going to be the area that is covered by both graphs, so right here. Some students like to do it this way, then erasing the non-overlapping region. I would suggest that instead you look at the compound inequality, identify the lower bound, 1, identify the upper bound, 4, paying attention to open closed dot, and then recognizing since it's an AND, we're going to shade the area between those two bounds. However, if it helps you to graph both simple inequalities on the same number line and then to erase the non-overlapping areas, that is fine as well. For an OR, a little more straightforward. An OR statement is graphed just by graphing the two OR simple inequalities on the same number line. So x is less than 1 or x is greater than or equal to 4. The solutions that make this compound inequality true are all the values of x that are either less than 1, so in this region, or greater than or equal to 4, so 4 or in this region. There's no value of x that is both less than 1 as well as greater than or equal to 4. You need to really pay attention to this OR. So either less than 1 or greater than or equal to 4. When you are graphing a simple or a compound inequality, you can immediately identify this is going to be arrows to the left, arrow to the right. This one will look like this, to the left, to the right. ORs are always arrows pointing out, ANDs are always overlapping regions shading the area in between. And open dot, close dot, open dot, close dot, open, open, open. That's supposed to be open, closed, open, closed, open.